Yep.
All right.
Good afternoon and welcome everybody to Harrisburg University's webinar series. This is the third to last in our series thus far. And before I introduce our distinguished guest today, I just want to remind everyone that this is a webinar format. So that you're not able to speak, you are in listen mode only, but we want this to be very, very interactive. So there is a Q&A section, and depending on what type of a device or computer you're on, it might look different, but there's a little icon with a question mark, probably up on the corner of your screen somewhere. Click on that, you can open that, and you can ask questions throughout the presentation. The questions won't be visible until the end when we get to the Q&A portion of the event, but please ask anything you want at any time. My name is Laurie Barrow. I am the Undergraduate Director of Admissions here at Harrisburg University, and we are glad to be presenting advanced manufacturing today for you all. So whether you are a parent, a high school sophomore, junior, or senior, or perhaps you've already applied and been accepted to HU, or perhaps you've even already committed to HU, you're going to learn a lot of really cool stuff today about advanced manufacturing. And if you don't know what it is and just came to find out, you're not going to be disappointed. It's actually a really interesting program of study, and it's one of very few across the U.S. And our guest today is Dr. Chip Shiro. Dr. Shiro is the program lead for the Advanced Manufacturing Program, and he's not only going to tell you all the great things about the program at HU, but also kind of explain why it's unique and why it's one of very few in the entire country, and kind of how it made its way to Harrisburg University. So with no further ado, I am going to turn it over to Dr. Shiro, and he is going to go ahead and start with his presentation, and I look forward to seeing you all at the end for question and answers. Thank you.
Good afternoon. Glad everybody's made it, and we're willing to get started and show you what advanced manufacturing is. It also has a little bit about what the manufacturing is, where it's coming from, why it's important, and we are going to hopefully have some fun doing it. Now, a little bit about myself before we get started. While I was working my master's and PhD, I was a public school teacher, which gave me insight on public schools. After I left that, being a public school teacher, I went on to Ohio Northern University, where I brought technology education into that university. Ford Motor Company went through and donated $4.5 million worth of robots. We also had a lot of virtual simulation software donated to us. And during that time, we did work with the Armored Cavalry. The Armored Cavalry work did anything from making objects disappear to building a GFI for the soldiers so that they didn't get hurt while they were out in the field servicing their equipment. After Ohio Northern University, I went to Johnson Space Center from 2000 to 2014. During that 14 years there, I built the largest data system that they have for manned spaceflight. That system has everything in it that an astronaut touches, whether it is a vehicle, whether it is a lifting body, it could be clothing, it could be tooling. In fact, the outhouse for the space station is in that system. That system still lives today. It's been renamed, but it's still there, and they're continuing to use it. During about 2014, 2012, the space agency was disassembled by a president, and at that point in time, after losing about half of my crew, which was 28 people, I went through and decided it was time to move back north. I was originally from Ohio, and so put my name out on the market, and within approximately 5 days, I had 7 offers, which one of them I took with TE Connectivity, which is here in Harrisburg. Worked with them on one of the largest data systems in the world on PDM Link. Their system is on 3 continents. It services 5 different militaries, and the architecture is quite complex. So I work security and architecture there. In 2017, they decided to go through and move their IT offshore. When they did that, they told 226 of us that we needed to find something else to do. But then they came back and had offered me a job with them, doing the same thing I was doing, but it had a different badge, and I decided that was not what I wanted to do. So I made a proposal to the president, the vice president of the university, and early there in 2017. And after about 15 minutes of presenting that presentation to him, the president stood up and he says, "Hey," he says, "you're hired and you start today." And I said, "No, I got to finish off what I'm doing." So that's how I got here to Harrisburg University, and that's how the program itself had actually started. Now, you might ask, well, what is advanced manufacturing? There's a lot of terms floating around out there, but let me tell you what it is and what it isn't. Manufacturing is the making of products for use, for sale, and they're done by using labor, tools, and machines and automation. That's how manufacturing works. As an advanced manufacturing student, what you'll find is you'll be interested in the tools, the machines, and the automation. You're a high-end person that knows what's going on and can fix things. Manufacturing is not anymore dirty, boring, low pay, sweatshops, dead-end jobs. It doesn't exist, not where you're headed. There are two pictures here on this slide. The one on the top left is of some gentlemen working in or even boys working in an area that appears to be sand ramming they're actually doing foundry work. That's the way it used to be. It used to be dirty and pretty bad shape. On the right-hand side and the lower right-hand side, you'll see people, hundreds of people, sitting at tables, assembling items. This is no longer done this way. It's now done with robots. That's your area. Now, this particular diagram is one you're going to see all over our website, and you're going to see everywhere you go. And it is basically our Industry 4.0, which is our advanced manufacturing. Advanced manufacturing does have two names, or actually three names: advanced manufacturing, Industry 4.0, and also smart factory. It's all the same. All those gold symbols that you see in the middle of it, including autonomous robots, system integrations, new processes, Internet of Things, simulations, compliant robots, additive manufacturing, subtractive manufacturing, cloud computing, digital twins, augmented reality, big data, networking, cybersecurity, all those things you will be introduced to in the program. You'll have a chance to try them. You'll have a chance to work with them. No, you will not be an expert at any of them, but you will know what they do and how they work and be able to advise your company and help them deploy that type of technology. Now, you'll notice also that there are 4 major international companies on there. Stratasys, which is a 3D printing company, or additive manufacturing. Mazak, which is a subtractive manufacturing company. ABB, which is our robotics company. And PTC, Parametric Technologies Corporation. That is one of our CAD packages, but they're much, much more than CAD. They are an end-to-end solution for the digital factory. That's the reason they are also supporting us. Between these 4 and about 20 other companies, they have gone through and donated $1.6 million to our cause in materials and in software and in equipment. They're all supporting it. Now, manufacturing is a complex opportunity that you can get into, and this particular cartoon means a lot to me because if you sat down and tried to put an elephant in your mouth and try to eat it at one time, it's not going to work. But if you take a fork and you break it up, you can eat it eventually. You can get it done. The manufacturing is the same way. Learning the technology, learning the systems. It's all piece by piece, which is the way we deliver it. Then we give you hands-on experience with it, and then you put it together. Now, the good thing for you that you'll be interested in is that by 2025, and you'll be graduated right around that time, there will be over 2.5 million open jobs available in your major area. 2.5 million jobs. Now, you're going to say, okay, that sounds great, but everybody else is going to want them. No. Right now, Harrisburg University is one of 6 universities in the world that's offering advanced manufacturing type programs. 2 of them are in the UK, and 3 are in the UK and 2 in Australia. We're the only one in the United States at this point in time with this type of program, a complete program. Now, manufacturing technicians. The only reason that's up there, and if you've had a chance to read it, that's good, but it's basically, it tells you what the government believes that you'll be doing. You'll be setting up and testing and adjusting manufacturing automation. machinery and equipment using a combination of electrical, electronics, mechanical, hydraulic, pneumatic, and computer technologies. A lot of big words, but believe it or not, everything in that sentence is going to be covered in our major. These are some of the job titles that have been pulled out of the government documents. These are not all of the jobs. There's a couple of things you need to see here. One of them is that you see a lot of them being called aerospace engineer or automotive engineering technicians. Sometimes it's technicians, sometimes it's engineering. Right now, with the government, they've gone through, and it used to be that engineers and technicians were all in one grouping, and now they're in two groups. One's engineering, one's technicians, or a technologist. Basically, what it comes down to is an engineer is a person that's willing to sit at their desk and do a lot of math to figure stuff out, and a technologist is a person that uses technology to solve problems. And yes, you may end up doing some math, or you may do some programming, but 90% of it's going to be hands-on, working with the machines and the tools. One of the pieces of equipment that is coming in is the laser. The laser cutter that we're having coming in is going to be capable of cutting about a half-inch steel. And if you think about that, that's a pretty good laser. We also have coming in a water knife. That water knife uses 30,000 pounds of pressure and some abrasive to cut through metals. The neat thing about this one is when you cut through these metals, you're going to find that with that abrasive, it's clean. You don't have to do any finishing of the surfaces. The only bad thing about this particular process is if you manage to get your finger in there and get it cut, you'll bleed, and it'll be just like a regular cut. Now, if you do the same thing on the laser while you're using it, it cauterizes, so it won't bleed. So you got to pick your tools as you need them. One of the biggest processes that's been online was brought out of Johnson Space Center by a man named Dan Rubicki, who was a friend of mine, and it's called friction stir welding. And they first developed this process to put the big tanks together on the shuttles, and it has been adapted and adopted by all of the aerospace companies, all the plane companies, the manufacturing companies that's coming mainstream. Basically, you push a mandrel through the aluminum, and it melts it, and the grain structure is so clean after being worked like this that you can't tell there's a weld there. And so this has been adopted, and it's even in the automotive industry. It's coming online. You will be doing this process. Additive manufacturing, or 3D printing, we will have the capabilities eventually, once the building's up, to be able to do anything from metal to human cells. We are going to be one of the first people, we're going to be one of 6 people in the United States that are going to have a stainless steel metal printer. We've been selected because of what we're doing, and you'll be able to see that eventually if you can come into the school. It is coming in the next couple of months. The top left picture and the bottom right picture are just objects that you cannot cut out of materials in one piece with subtractive manufacturing. This is one of the unique things about additive manufacturing. The top right picture is a picture of a house being done in concrete. This is kind of an artist's rendition, but I did see a printer large enough to do a whole room actively running and printing a room in concrete. It can be done. They've worked out the technology. The technology uses, if you ever seen a professional football game and you see the camera flying down through the center of the field, and you can actually see it moving around. That same technology is being used. The only difference is instead of taking pictures, it's laying down concrete as it's being printed. The bottom left-hand picture, I've saved that for last for a reason. Right now in Northern Ohio, there are 2 manufacturers, and I won't mention Ford and Chevy, but they've emptied out parts of production lines, and they're actually going through and building 3D printers that are large enough to print cars. Now, you might say, do I really want a plastic car? And your answer is you say no, because with the 3D printing coming along to metal printing, which I just told you we were going to be part of, they can actually print the body of a car. They can print the frame of it. They can print the engine. Okay, so that technology is coming on so fast that the automakers are already moving towards it. And if you stop and think about it, they're building this stuff, but they don't have anybody to run it. That's where you come in. Now, there's a lot of systems. I've talked about systems in there, and one of the quotes I really like from Shrek is that onions have layers and ogres have layers. Do you get it? When he was talking to Donkey, and the reason I like that one is all the automation that we talk about, all the automated machines, they all have layers, and if you start out with the beginning layers and work yourself through, you'll be fine. System integrations. On the left, you see a set of robots and a whole bunch of automation, which is actually a unit that is lights off, which means they can turn it on and walk away from it. It works all by itself. Those things get out of whack, and they do need service. They need help, and that would be your place. The picture on the right with a gentleman underneath a car. I think it's a car. Maybe it could be a pickup. We don't know, but it appears to be a car. And one of the things you got to realize is that as you're working with automation, not only do you have to work with the machines, but you may have to work with humans too, because I don't think humans are going to go out of the manufacturing process at all. They may go out of some parts of it, but most of the time they're still going to be in the cycle. So you got to remember the human factor when you're working on that. Digital twins. This is something that's very, very important, and it's coming online. I shouldn't say coming online. It is online for a lot of major companies. Basically, you see a robot there that's looking into a tablet. He's looking in the tablet trying to fix something. Somebody told him he had a screw loose. That's the reason he's trying to fix his head. This is real time today. It exists, and they need people to work it. Now, a digital twin is a bridge between the physical world and the digital world. It's basically you take a CAD drawing, and I'm going to show you. I'll go ahead and switch to it now. You take, you see a gentleman on the bike. This bike was done in the software package called PTC Creo, and then it was transferred. The data was being transferred in from the bike with sensors into ThingWorks. So you got a CAD drawing of the bike itself, and you use ThingWorks to bring that information into the CAD, and you do analysis on it. What this allows you to do is to do real-time checking on items, and they're already doing this against cars. They're doing this against trucks. It's already there. What happens is, with that data being in there, the CAD system, you see this tablet being held up. When it sits in front of that bike, it sees the bike. It sees the identifier on the back spokes, and it automatically shows you what each one of those sensors are sensing. They do the same thing, and there's going to be other examples of it. That same things are going on for training and also for servicing items that are coming out of manufacturing. We simulate just about everything in the world. We simulate part stress. The red areas are areas where the parts are stressed. We do work cells. We do factories. The machine tools that we verify. There's two pictures there. The one on the left is the simulation itself. The one on the right is a real cutting item. A little quick story on this is when I was down at Johnson Space Center in 1995. They were going, no, 1998. They were going through and cutting what's called the bulkhead for the X-38, and it was a piece of aluminum. It was about 1.5 feet thick, about 8 foot wide, and about 12 foot long. And they had spent 4 days cutting this out. It had to be in one piece because it was a spaceship. And they got down the last 4 or 5 hours, and the cutting tool took off and went to the side of it and destroyed it. And they lost $250,000. Well, of course, the next day, Frank Benz, who was the head of JSC, came to our office area, and he took us all to the meeting room, and we all sat down. And after he settled down, he said, "Why didn't we see this coming?" And the programmer says, "Well, we couldn't see it. We did what we were supposed to do, and the code said it was okay." And he asked again, "Why can't we see it?" And so I raised my hand, and at that point in time, I got a lot of glares. But I told him, I said, "I brought 2 students down here with virtual simulation, and I can simulate that, and I can show you exactly where it is and how it was going to affect it." And he says, "How long? Is it going to be weeks?" And I said, "No, give me a day." And the students and I broke away from that group, and within about 4 hours, went back to them and showed him with a video with a code running next to it exactly where it was going to break and how it was going to break and why it broke. And from that point on, Johnson Space Center now uses virtual simulation. So that's just kind of an inside story. Autonomous robots. We got autonomous robots coming in. There's several different kinds. You've seen them out there where they have legs and they're walking around, and they kind of look like animals and stuff. Another autonomous robot are the robots that work in factories. They're on the right-hand side of the screen. Those guys used to follow wires in the floor, and now they no longer do that because if they got behind something on a wire and they couldn't move, they were stuck. Nowadays, they go by GPS, which means that if they get stuck, they let the computer know that they're stuck. The computer figures out where to send them, and they work around the outage. That's how advanced the technology is. The the bottom left-hand corner is a autonomous robot that goes in and takes a look for bombs. And of course, that's just another use of the autonomous robots. Compliant robots are really cool because they are on the cutting edge, and they're more cutting edge than you would believe. The compliant robots, the one that's in the top left-hand corner, is from ABB, and we have two of those coming in. They have vision, and they have tactile sensors that look like hands. And basically, a compliant robot you can sit with, and you can work with that robot. And when you're done working with that robot, or it gets in your way, you can shove it out of the way, and it will wait for you to be done, and then it'll come back and finish its work. So that robot can't hurt you. A regular robot can, that one can't. Now, one of the pictures, these others are pictures of robots that are compliant. We have down the bottom right-hand corner, and it's something I want to point out, is that you see that face right there? That face is a head for a robot. If you take a look at the picture just to the left of it, you remember seeing iRobot, and they said all the robots are coming out with these white faces and blank expressions and everything. Don't bet on it. Your robots are going to come out looking like humans. And so you may, in your lifetime, I will bet that you will be working around a production line with robots that look like humans. I fully believe that. The other thing we talked about was the Internet of Things, IoT, the information that gets added to these drawings to make them real. Any device that you have Wi-Fi enabled, any device that's plugged into a 110-volt line in your household, a regular plug, whether it be a microwave, a washer, a dishwasher, a dryer, your TV, your computers, your tablets, your phones, all use that communications. All that communications is collected, whether it's voice, whether it's text, whether it's video, it's all collected, and it goes back to either one or two places. It goes back to the manufacturer itself, or it goes back to the government, and the government collects that information. And so that's how they track threats. And basically, it all goes down to Dallas-Fort Worth, and the guy that made the database, I have met and have worked with. So is it true? Yes, it's true. In the digital world, you do not have privacy, and just keep that in mind. Now, in IoT, Internet of Things, it's also called IIoT, Industrial Internet of Things. And basically, you have somebody who owns a company on that top layer, and he's got 6 or 7 places around the world, and he knows there's a problem, and he wants to find out what's going on. So he drills down to the second layer to find out where the manufacturing is being done and in what country. And then once he gets to that point, then he drills down and finds the floor, the manufacturing floor, and he can actually see through the data what's going on that production line and whether it's doing well or not. And that's at that point in time, that's when somebody like you is called upon, and they're going to say, hey, there's a problem here, fix it. And you'll be the one that comes in, you'll figure out the problem, you'll present a solution. Once you've presented your solution, they'll accept it, and you implement it, just like that. So it's not you probably won't be doing the same thing day to day unless you want to do that. It'll change. Now, there's 2 different types of reality. There's augmented reality and virtual reality. Our field deals a lot more with the augmented reality, but virtual reality will be used. Augmented reality is on the left. That's where you use a tablet, and you project onto that tablet what you want the person to do, and direction-wise, and they can go through and locate items and perform tasks with that. On the right-hand side, you're going to see an actual virtual simulation or a virtual reality. That virtual reality on that side, you can see the man actually manipulating the parts of the pump. That pump is sitting right there in front of you on that block. Okay, so the difference is with the augmented reality, you're not touching it. With the virtual reality, you're actually touching what's going on, and you can interact with it. Now, the big thing is the IoT, the Internet of Things. Its future is bringing the physical world back into the digital world, and the augmented reality's job is to bring the data from the digital world back in the physical world. So both of them are married together, and both of them are very, very important. And we do have a full semester's class on that. Cloud-based technology, these are all everything's going to the cloud. You hear that every day. There are different clouds and different rates of clouds. There are public clouds and there are private clouds. We will deal mostly with the public type clouds. Things that are going on in the cloud include blockchain technologies. That means traceability of items from the manufacturing start point to the shipping point where they leave the factory. Each time that part goes through some type of process, it is scanned. Once it's scanned, then it moves on, and that's how they keep track of it. That way, if you make 1,000 of parts and you know one of them came out that was bad, let's say number 400, and you make them in batches of 50, then you only have to pull 100 parts instead of the whole batch to see which ones are bad, because you'll know exactly which ones are messed up. Integrated product design, you'll be working with people around the world, or can be working with people around the world on the same project at the same time. The technology is here, it's being used. There's also quality assurance that's going on, whether you're trying to keep stuff that has been manufactured or it's just getting ready to be manufactured. You got to check the quality on the stuff, because if you have poor quality coming in, you get poor quality going out. Real-time tracking and traceability. I really like this one, and the example is Amazon on this. Basically, if you go to Amazon and you buy something, they're going to send you an email that says you bought this. They're going to say it's being packed, it's being transported, you're going to receive it on such date. That is real-time tracking, okay? And that real-time tracking is also going on in manufacturing today. So be prepared. You're going to get a lot of emails. Now, this is one of the unique things about the program itself. This uniqueness is very important, and you want to listen up on it. Normal programs, when you come into any university, and I mean any university, you come in a big funnel, they take in hundreds of people, and they put you out into different majors, okay? Our program's different. You come to us, and you come into our program, and we introduce you to many different areas of study, and you get to do hands-on on them, and then you get to decide in the end which one you're going to work at. So that's very important to note that you may get introduced to 10 or 12, maybe 15 different areas, and when you get introduced to them and you understand them, you'll use them. But then at the end, you can choose who you're going to work for by what you want to do. You make those decisions. This is the new building that's being built. The neat thing about it is our program is going to occupy the 17-story building is going to occupy 3 floors, about 13,000 square feet. It is an investment of $40 million in this program. That means you're amongst the first to come through and experience it. Of that $40 million, $10.2 million of it are the machines. Everything that we do is state of the art. Everything will never get any more than 3 years out of date. If by chance something in the curriculum changes and we need to take a technology out and put a new one in, I can do that within a month. Everything is modular, so we'll be able to take care of that. We're looking at supporting about 260 students. I'm hoping for 220, 240, but I think we're going to go to 260 on that. So there's going to be quite a few of you. These are the friends of advanced manufacturing. These are the people, you know, it's the ones on the front page, the big 4 in there, but these are the people that have donated a total of $1.6 million. The other side of the coin of this is that right now, in Harrisburg and right around Harrisburg, I have waiting 60 jobs for graduates. They've already been committed to. On the national level, there's another 150 up there. So think about that. It's most majors you go in, and you're going to go in and have to find a job when you leave college. With this major, you won't have to go find a job. You'll have to figure out which one you're going to take. And you notice those companies are national, some are international, some are even government. There's NASA in there, which I still have ties back into NASA, and there's Sandia Labs. Sandia Labs offered to fly people down. They offered to fly 30 people down for an internship and let them and house them and feed them and fly them back after a semester. And they would have worked for the government and been able to work for them. The only problem I have with it is what you do at Sandia Labs, they typically don't tell people about. So I may not know exactly what you were working on down there, but they're looking for people. They want 30 people alone, is what they're looking for. Ford Motor Company's asked. Penske Racing is asked. Racing is looking for 5. Ames is looking for a dozen if they can get them. These are name brands. You know, Stratasys would like to have 50 or 60 people, and they don't have people. So keep in mind that we are the first program in the United States of this type that is comprehensive, and we're one of 6 in the world, and we're probably the most comprehensive of the 6 in the world. Remember that when you leave here, you're not going to go looking for a job. You're going to end up having jobs come to you. Don't forget my 2 pictures. Shrek with the layers. We work with layers. Even if you don't know anything about manufacturing now, we can fix that. And then we also have the one bite at a time with the elephant. So I want to thank everybody for showing up, and hope that everything goes well for you. Be safe.
Thank you so much, Chip. That was wonderful. I'm sure everybody in our audience really enjoyed learning more about the Advanced Manufacturing Program. I think that it is one of 6, really around the globe, is so impressive, and what a great place to be right here in Harrisburg if you want to get into cutting edge technology. And you guys are going to be taught by really one of the best in the industry. So really appreciate you being here today, Chip. We do have some questions from the audience. Before I do that, I just want to make sure everybody knows this is being recorded. I did put it in the comments, but if you didn't see it, it will be recorded. And once we have it saved and downloaded, we will forward that to everyone who registered for today's event. In case you would like to review it again, share it with mom and dad, send it to a friend, whatever you'd like to do. And before I get into some of the specific questions, Chip, I don't know if you mentioned it. I didn't hear it. Did you get a chance to talk about the project that you are currently involved in with making the face shields?
No, apparently I didn't.
I'd love to hear about it.
We are currently building face shields for the front responders, and basically we build a visor using 3D printing technology, and then we put a shield on the front of it. We've delivered almost 600 of these shields to local area people, for rest homes, for hospitals, wherever they need them. And it's one of these. There is actually a national movement trying to do this with Stratasys, and they've delivered at least 10,000 of them, I think. But locally, we're taking care of our own.
That's awesome. I feel really good about working for a university that's using what we have to give back to the community and really to the globe. So that's a wonderful initiative. Okay, so I'm going to go to our first question. Comes from a member of our audience, and they'd like to know, what are some examples of things students have created? Can you give us some ideas of some things that some students have created within the Advanced Manufacturing Program, or that you anticipate they're going to be creating, perhaps in the upcoming years?
That's a that's a good question. The things that are going to be built are basically endless. The technologies we have for subtractive manufacturing, additive manufacturing, mean that as long as you can sit down and design it, we'll be able to produce it. It can be anything from something small. There's one of our students right now has a prosthesis, and he is in the process of redesigning his hand, and we plan on printing it out for him. It can be something like that. That can be complex, or it can be something that's simple. We have another student that's working on a lift device that would be on the inside of a Pringles can, because if you get Pringles and you got to reach all the way to the bottom, you got to turn them upside down and bust them. Well, he's figured out how to build a device that goes inside the Pringles can, isn't very heavy, and can actually bring them to the top. So that's, there are things like that going on.
That is really neat. I did not know we had a student with a prosthetic in our program, so I'll have to keep an eye out for that, but that's really neat stuff. That's great. So if you can dream it, you can make it, is what it comes down to, it sounds like.
That is exactly right.
Awesome. We have another question here from the audience. They're inquiring about, your opinion or government data about entry-level positions in this industry, what the salary might look like. I know that it does depend, of course, on exactly what the position is and, of course, where you live in the country, but could you give a ballpark?
The ballpark, based on the research that I've seen, is people are going to start out somewhere between $55,000 and $80,000, somewhere in there. The reason for that is that because of the skill sets you're going to have, but I will warn you up front that if you get in at those numbers, you're going to find yourself quickly moving up through the pay scales, because once you get into a company, you become a integral part of their production, and they can't do without you. And if you end up like I was at NASA, I carried 3 phones. I was not allowed to leave when they were landing, launching, or docking. I was not allowed to leave. My vacations had to be done between flights. So remember that you will become an integral part of that company, and your pay, that's only a starting point for the pay, and it will go up from there.
Wow, so there's really a return on investment with this program. This isn't like going to school and studying English or history or psychology. This is something that if you get this degree, you're really a hot commodity.
Yes.
And it's only going to get better, and I'm sure more expansive. And as these programs grow across the US and maybe across the globe, think about that. They're going to be kids just getting into this field, whereas you've been in the field now for a few years, and now you're really in position to teach and to manage and to be the kingpin there in a company. So that's really interesting stuff. Mm-hmm. We have a comment actually from Colleen in our audience, and I thought you'd appreciate this, Chip. She said, "I don't have a question, but this seems like an amazing program." So you are touching people and you are explaining just how cool the program is, and I wanted to share that with you.
Thank you.
You're welcome.
I appreciate it. That's she's right too. This program is built in a way that hopefully within a few years there will be other people that want to reproduce it, and that it can be moved out and get more people, because I can't graduate 2.5 million people, not for those jobs. I'll try, but we're not going to get 2.5 million out there.
Wonderful. Another question here regarding getting a master's degree. So the student is asking, I'm sorry, I'm not sure if it's a student or a parent, but the audience member is asking, do you suggest students with this degree get a master's, or does a bachelor's degree suffice? How would you answer that?
The bachelor's degree suffices fine. But if you have interest that you might want to do something in management, or you might have an interest, let's say, in advanced manufacturing concepts, there will be a master's degree here at Harrisburg University, and then you can also go through and do business or whatever you want to. It's a master's won't hurt you, but this degree will prepare you to take just about any job that's out there and be able to run it. So it depends on your interests, what you want to do.
Okay, thank you very much for that answer. We do have a question here that came in. The student is aware that we are building new facilities, that we have a new building, that advanced manufacturing is going to be taking up a big part of that. And I know that we have a lot of brand new machinery, and so they said they're excited to see some of the new machinery. I thought maybe you could talk a little bit about some of the new machinery that we've gotten, and maybe what some of the benefits will be to the new building once it's completed for your program.
Okay, some of the equipment we've started bringing in were the PLCs, the programmable logic controllers. We've brought in electronics trainers. We've brought in pneumatic and hydraulic workstations. We've also brought in part of our 3D printing or additive printing equipment. One of the machines we brought in is called a Fortress 450. It's one of the mainstays, main 3D printers that industry uses. That particular item is where we're running all of our visors for our face shields. We have a U-print. We also brought in a J850, which is a polyjet, and on a polyjet printer, I can actually print a replica of a pineapple, and you can't tell that it's not a real pineapple. Any color that, if you go to Home Depot or Lowe's and you pick out a color, it has a color code on the back. You bring me that color code and I can match that color code in whatever you want to build. So that's the type of technology. And then again, within a couple of months, as soon as this virus thing lifts, we're expected to be one of the first 6 people in the United States to have a stainless steel printer, and it'll be here in the university.
That is so cool. That is wonderful. I can't wait to see all that myself. I'm going to spend a lot of time up in your lab this year when we get back to the university. Check this stuff out. We have another question here from one of the registrants for the program who gave this question beforehand. And they are interested in knowing maybe when will they actually be able to get their hands on the equipment? Meaning, are they going to have to do all their general ed studies as a freshman and sophomore and not get into the good stuff until junior, senior year? Or when do they get in there and have fun?
That's an excellent question. The first semester here at Harrisburg University, at least it's my impression, you can correct me if I'm wrong, is the students go in, all of them go in against one particular set of courses, and everybody takes the same thing. During the second semester, it's our first opening of the second semester of the first year. It's our first opening to pick up classes, and we start looking at the CAD classes, and we start looking at we have an intro to manufacturing, and basically what that class is we go in and take a look at your computer skills to make sure that you can run the normal softwares, and then we put in some management type softwares in there. And then we do some management concepts like, oh my goodness, we do concepts with quality control, and that class is basically set up that way because everything in that class is going to be used for the next 4 years. So the second semester of your first year, you do hit the courses, and then your second year, you get more into the courses, and by the third year, you're almost all courses. So you do get your fingers wet, yes.
Okay, great. And I think we have time for 1 or 2 more questions here. So I'm going to go with a question about math. Student wants to know really, how good at math does one have to be? And that's always a question for a lot of different faculty members. But they said, I know I have to take college algebra and statistics, but in looking at the catalog, they saw that there's a Math 104 course called Applied Mathematical Reasoning, and they're wondering, what that is. Is that like a calculus? Is that geometry? Is that harder? Is that easier? Curious what they're going to be getting themselves into.
That's an excellent question. Basically, what you're looking at is if you come out of high school and you can do Algebra 1, Algebra 2, and do some geometry, you're in good shape. This whole program is designed based on the math that you need to do your job, not math that you could use someday in the future. That math course that was just mentioned, the applied math, is a real neat course. We took a math course out of the major that was just killing the students, and we put this one in, and it's a very practical math. It's all practically applied. You get to work with different numbering systems, and when they build it, I had them build in what we were doing. Now you do have to take a statistics course because you're going to end up doing proposals for companies, but it's not a painful statistics course. Okay, so if you take that with the applied math course of 104, I believe is the number on it. If you take the 2 of those together, that takes care of your math, most of your math, and so you'll be okay. Math, if you can always work around math, and if you're worried about, the other thing is people get worried about doing is a bunch of programming. Good programmers, which is what our technologists consider ourselves, are people who borrow code and change code and fix it. It's much easier to read a piece of code than it is to write it from scratch, and that takes a different type of person, and you won't be asked to do one from scratch. You will always have examples on stuff to use.
All right, that is awesome. Well, that really brings us right exactly to 2:45, so we're at the end of our webinar presentation today. I want to thank you again, Dr. Shiro, for joining us here. I know everyone's busy with virtual learning and different projects, so we appreciate you taking the time out. I know our audience appreciates it as well. We're really thankful that you all joined us today. We hope you learned a lot. If you have additional questions, you can certainly reach out to us here at admissions. You can email us at undergraduateadmissions@harrisburgu.edu. We can also make sure that you receive Dr. Shiro's email address when we send out the webinar recording. I know that he'd be glad to take additional questions or more specific questions you might have. So with that, I'm going to say goodbye and thank you, and keep an eye on your email for the recorded webinar. Have a great day, everybody. Bye-bye.
Goodbye, everybody.